Solve the following rational equation for u. And here we are given u minus 5, all divided by u minus 1, is equal to u minus 6 divided by u minus 4 plus 1. So the first thing that we need to do here is find the least common denominator. Now we want to find that least common denominator to remove the fractions. So find the LCD, the least common denominator. So looking at our first fraction, we see that we have a denominator of u minus 1. So that will be part of our least common denominator. And the other fraction has a denominator of u minus 4. So that also must be in our least common denominator. So there's no other terms in the denominator, so that's it. Woohoo! Now, while we're here, these are the factors of the denominator. So let's go ahead and find out, where does this function not exist? So we want to find the zeros of the denominator. So to do that, all we need to do is take our least common denominator and set it not equal to 0 and solve for u. So we have u minus 1 times u minus 4 cannot be equal to 0, right? Because division by 0 is undefined. And we have two cases to consider here. We have the case u minus 1 cannot equal 0. And case number 2 is u minus 4 cannot be equal to 0. So in case 1, to isolate u, we're going to add 1 to both sides of the equation. Minus 1 plus 1 cancels itself out to 0, showing us that u cannot be equal to 1. And in case 2, to isolate u, we add 4 to both sides of the equation. Minus 4 plus 4 cancels itself out to 0, leaving us with u cannot be equal to positive 4. So we're going to want to keep these two undefined values, or the zeros of our denominator, in mind, particularly at the very end. Right? Because we know u cannot be equal to either one of these values, and we want to make sure that they are not solutions. So here we go. We're ready now officially to start solving for u. So we are going to take our original rational expression. We have u minus 5 divided by u minus 1, and this is equal to u minus 6 divided by u minus 4 plus 1. Now, to remove the fractions, we are going to multiply both sides of this equation by the least common denominator, which is u minus 1 times u minus 4. And of course, whatever we do to one side, we must do to both sides. So we're multiplying by u minus 1 times u minus 4. Now notice on the left-hand side that we have u minus 1 in the denominator and u minus 1 in the numerator, so those terms will cancel each other out to 1, leaving us with u minus 4 times u minus 5. Now on our right-hand side, we need to take this least common denominator and distribute it through to both terms. So this is going to be rewritten as, we have the rational expression u minus 6 divided by u minus 4, multiplied by our least common denominator, u minus 1 times u minus 4. And then we also have plus 1 multiplied by the same least common denominator. So giving ourselves a little bit more room. This 1 is also multiplied by u minus 1 times u minus 4. So here we go. We can see on our right-hand side that we have a u minus 4 in the denominator and a u minus 4 in the numerator. So those terms are going to cancel each other out to 1. And we are left with a beautiful linear equation now. We have u minus 4 multiplied by u minus 5. And this is now all equal to u minus 6 multiplied by u minus 1 plus u minus 1 times u minus 4. Okie dokie. So we've got a lot of expansion to do here. So starting with the binomial product on the left-hand side, We have u times u, which gives us u squared. We have u times negative 5, which is a minus 5u. We have negative 4 times u, which is a minus 4u. And last but not least, we have minus 4 times minus 5, which leaves us with plus 20. And we see that our two intermediate terms are like terms, so we can rewrite the left-hand side as u squared minus 9 times u plus 20. So moving on to our right-hand side, the first binomial product, we have u times u, which is u squared. We have u times a minus 1 for a minus u. We have negative 6 times u for a minus 6u. And then negative 6 times negative 1 is plus 6. And again, those two intermediate terms are like terms. So we are left here with u squared minus 7u plus 6. And last but certainly not least, we have the second binomial product on the right-hand side, u times u, which produces u squared, u times minus 4, which is a minus 4u, negative 1 times u is a minus u, and negative 1 times negative 4 is plus 4. Those two intermediate terms are like terms, so we can rewrite this as plus u squared minus 5u plus 4. Beautiful! So now notice, looking at the terms on the right-hand side, we have a lot of like terms here. We see that we have a u squared and a u squared. We have a minus 7u and a minus 5u. And last but not least, we have a constant 6 and a constant 4. So let's rewrite this. The left-hand side will still remain as u squared minus 9u plus 20. And now this is equal to u squared plus u squared leaves us with a 2u squared. Minus 7u minus 5u is a minus 12 times u. And then 6 plus 4 leaves us with plus 10. Phew! So at this point, we want to recall that in order to solve for u, we need to set this expression equal to 0. So noticing that we have a larger u squared on the right-hand side, I'm going to begin by subtracting u squared from both sides of the equation. And we can see u squared minus u squared goes to 0. We have a plus 9u to both sides of this expression. And a minus 9u plus 9u cancels itself out to 0. And last but not least, I'm going to subtract 20 from both sides of this expression. And we have 20 minus 20 cancels itself out to 0. So we are now left with 0 is equal to 2u squared minus u squared leaves us with 1u squared. We have minus 12u plus 9u leaves us with a minus 3u. And then 10 minus 20 leaves us with a minus 10. Whew! So now we're ready, officially ready to start solving for u. And I'm simply going to rewrite this so that I have u squared minus 3 times u minus 10 is equal to 0, because I like having my variables on the left-hand side. And we're thinking to ourselves, what two numbers multiply together to give us a negative 10, but combine together to give us a negative 3? Negative 5 and 2. Woohoo! So we can rewrite this as u minus 5 multiplied by u plus 2. And this is set equal to 0. And now we can think about these two binomial cases. We have u minus 5 is equal to 0. And case 2 would be u plus 2 is equal to 0. So solving case 1 here, to isolate u, we're going to add 5 to both sides of the equation. Minus 5 plus 5 cancels itself out to 0, leaving us with u is equal to 5. And very similarly, in case 2, to isolate u, we are going to subtract 2 from both sides of this equation. So 2 minus 2 cancels itself out to 0, leaving us with u is equal to negative 2. Now, before we get excited and box up our solutions, we need to check. So what were those undefined values that we found at the beginning? So we know that u cannot be equal to 1, and u cannot be equal to 4. So neither solution is 1 or 4, so we're all set. And we can say that therefore u is equal to 5 and u is equal to -2. And this is our beautiful final answer.